Now, before moving on to the next topic, let me remind you guys that this is how we proceeded in the function with multiple variables. We discussed the definition of function with two variables, and then we learned how to calculate the domain and range perhaps for a function with two or three variables. We learn how to differentiate function with two or three inputs partially, and then we have seen some fascinating applications of function of multivariable in terms of unconstrained optimization and constrained optimization, or Lagrange multiplier method. We also understand the process of integration in two variables. We call it multiple integral. Now it's time to explore more applications of function with multiple inputs. Now, to begin this idea, let me first introduce to you the definition of differential equation. So here is a formal definition of differential equation. Let's try to understand what is differential equation. A differential equation is a relationship between dy by dx and function with R2 input. Alright, so it's a very simple and straightforward definition. A differential equation, it's a relationship between derivative of y with respect to x and function with inputs x and y. Mathematical notation, again it's a fairly simple notation. You just set dy by dx and function with two inputs equal to each other. So it's a formal notation of differential equation. By now it should be clear in your mind that producing examples of differential equation is fairly simple. All you have to do is put function with two inputs on the right side, and left side you set it as dy by dx. Here are a few obvious illustration. Let's say I give you this function, this differential equation, dy by dx equal to x square plus 2xy plus y to the 5 plus 7. Right? We can construct a differential equation with right side in the format e to the x square plus y cube plus log xy square plus 2x plus 3y. Here is another example of differential equation, dy by dx equal to 2x cube y5 e to the x square plus y plus log 7y cube plus 9. Alright, so by now it should be clear that producing an example of differential equation is more or less very simple. So now let's write down few obvious remarks that are associated with this definition. The first remark is about the solution of differential equation. In general, differential equation are very difficult to solve. In many cases, if the right hand side is a random function of x and y, very ugly function of x and y, then it might happen that we will not be able to solve that differential equation using the available techniques that we are going to learn. Alright, so in many cases they are unsolvable. So let's write it this way. Suppose the method that we are going to study help us solving the differential equation, then I would like to give the solution a name. All right, the solution of differential equation if exist is called the general solution. In short, I will write G dot S to represent the general solution of differential equation. Alright. I would like to give you one more definition related to this differential equation. It's a definition of initial value problem. Initial value problem, or IVP. This is the practical form of a differential equation. Alright, it's a differential equation with some initial data given. Alright, so a DE, or differential equation, with initial condition is called initial value problem. As I said, in short, I will be writing IVP to represent initial value problem. Alright, would like to give you one remark here. Alright, it's a pretty simple remark. The solution of IVP, of course, if exist, is called the particular solution. In short, I will be writing P dot S to represent particular solution. Alright, so let's keep these things in mind. We have a definition of differential equation. It's a relationship between dy by dx and function of two variables. Pretty easy to construct examples of them. However, in general, they might be very tedious or difficult to solve. In case if we are able to solve it, then we are going to call the solution general solution. And then from a practical viewpoint, we consider differential equation with some sort of initial data given, and this initial data we would like to differential equation with initial data, we would like to call it initial value problem.